your time watching the following video. I'm Dimay Sarodi, and today we're going to cover the next topic, which is common factor property. This property is inverse to the distributive property. If you haven't seen the previous video, I suggest you to watch it because this is the inverse to the distributive property. Anyway, the common factor property states that if several addends have a common factor, we can transform the addend into a product by extracting that factor. In other words, for example, in number 1, if you have this operation and you notice that there's a common factor, in this case is in number 2, you could say you could extract that number by creating a product. In other words, 2 times 3 plus 5, and this would be the application of the common factor. I extracted the number 2 and I created this operation. If you want to verify if you apply the common factor properly, then you can just multiply it again by applying the distributive property. Therefore, remember that the 2 is going to multiply the first term and the 2 is going to multiply also the second term. In other words, 2 times 3 plus 2 times 5, and this is the same as this. Therefore, the answer is correct. This is the correct form of applying the common factor. Let's check out problem number 2. In problem number 2, we have a similar case, but now we have more 3 multiplications. But we can notice easily that the common factor of these 3 operations is the number 2. Therefore, I could extract the number 2 of the addends and transform this into this form. 7 plus 8 plus 3. If you want to verify again if this is correct, then we could just apply again the distributive property to see if this common factor property is correctly applied. So it's going to be 2 times 7 plus 2 times 8 plus 2 times 3. And this is the same as this. Therefore, it was correctly applied the common factor property. Anyway, we have this last problem, and you may be asking yourself, how do I solve this? Okay, so, well, we know in hand that the answer to this is 10, right? Because 20 plus 30 equals 50, and 50 minus 40 equals 10. But here, we could say that the 20, the 30, and the 40 have a common factor that is not seen directly, which is, for example, I could say 2 times 10 equals 20, right? And 3 times 10 equals 30. And 4 minus 4 times 10 equals minus 40. Now, I have noticed that there's a common factor, the 10. Therefore, I can extract the 10 and say that this is multiplying 2 plus 3 minus 4. And this would be the way to apply your common factor property. And you perhaps maybe ask yourself, is this correct? Well, we can just verify it in a numerical way, right? The result of this is 10, so this should be also a 10. So 10 that multiplies 2 plus 3 equals 5 minus 4 equals 1. Therefore, the answer is 10. And this is the same as this. Therefore, our whole process was correct. Okay, let me explain it again. So first, in this case, we have to try to factorize the numbers. And I have noticed that all of this can be divided by 10. Therefore, 2 times 10 equals 20. 3 times 10 equals 30, and minus 4 times 10 equals minus 40. I could also say that minus 10 times 4 equals minus 40, but I was arranging the numbers in a way that it would be more convenient to me, right? If the 10 was negative, therefore I could not extract it because minus 10 is not the same as 10. That is why I chose the negative sign for the 4. Anyway, I extracted the number 10 and I said 10 multiplies 2 plus 3 minus 4, which we already know that several addends have a common factor. We can transform that addend into product by extracting that factor, and this is how we apply the common factor. This is just the inverse process of the distributive property, and this will be very useful in algebra when you try to factorize by common factor, and that is why you learn this. Remember, the problem is not your capacity, it's assuming that you cannot achieve it. See you in the next video.